The television direct-to-home remote control is an everyday handheld device that seems remarkably simple on the outside, yet it functions as a finely tuned electronic instrument on the inside. At the heart of its operation are four primary components working in seamless synchronization: a printed circuit board, a microcontroller integrated circuit, a silicone rubber keypad, and an infrared light emitting diode. Understanding how a DTH remote control works requires examining how human mechanical pressure transforms into an invisible, coded signal that travels across a room to change a channel, adjust volume, or navigate a digital menu. Everything begins at the physical interface where the user interacts with the remote, the silicone rubber keypad. Beneath the soft, flexible buttons that display numbers, arrows, and function labels are conductive carbon pads. The keypad rests directly above the printed circuit board, which serves as the physical backbone and structural framework for the entire electronic assembly. Printed on the surface of this circuit board are non-continuous, open trace paths arranged in interleaved patterns resembling small, interlocking combs. In its default state, when no buttons are being pressed, these circuit traces remain open, preventing any electric current from flowing. This passive state is crucial because it ensures that the remote control consumes virtually zero battery power while sitting idle on a table. When a user presses a button on the silicone keypad, the flexible rubber collapses downward, pushing the conductive carbon pad on its underside against the specific set of exposed PCB traces beneath it. The carbon material bridges the physical gap between the traces, acting as a momentary switch that closes the electrical circuit. This physical action immediately alerts the microcontroller integrated circuit, which acts as the intelligent brain of the remote control. The microcontroller is a compact microcomputer etched onto a single silicon chip, programmed specifically to monitor the matrix of switches on the PCB. It operates on extremely low power supplied by standard battery cells. The matrix layout allows the microcontroller to identify precisely which button was pressed by scanning the grid of row and column traces on the PCB. Each specific key on the remote corresponds to a unique digital binary code, a distinct sequence of ones and zeros. For instance, pressing the volume up button triggers a specific binary pattern, while pressing the power button generates an entirely different code. The microcontroller's primary job is to instantly detect which circuit switch closed, look up the corresponding digital signal in its internal memory, and translate that mechanical input into an encoded electrical message. Once the microcontroller retrieves and formats the appropriate binary code, it cannot send this signal directly through the air as electrical current. Instead, it must convert the digital data into a light wave format that can travel wirelessly to the television set or DTH set-top box. This is where the infrared light emitting diode comes into play. Mounted at the top edge of the remote control, pointing toward the television, the infrared LED serves as an optical transmitter. Because standard static light cannot easily carry detailed digital information and would be easily disrupted by ambient room lighting, the microcontroller uses a technique called pulse distance or pulse width modulation. The microcontroller rapidly turns the infrared LED on and off thousands of times per second. It pulses the light at a specific carrier frequency, typically around 38 kHz. This rapid flickering creates a precise pattern of light pulses and pauses that represents the binary code generated by the microcontroller. Although the human eye cannot detect this light because infrared radiation falls just beyond the visible light spectrum, the sensor on the DTH set-top box is designed specifically to detect this exact wavelength and frequency. When the light pulses leave the infrared LED, they travel through the room in a straight line or bounce off smooth surfaces like walls and ceilings. At the receiving end, the DTH set-top box features a small optical sensor tuned to 38 kHz. When this sensor receives the incoming infrared light pulses, it filters out background noise from household lamps or sunlight and converts the light pulses back into electrical signals. The internal processor within the set-top box then decodes the binary sequence, recognizes the intended command, and executes the requested action instantly on the television screen, such as increasing the volume or tuning to a new channel. The overall engineering design of a TV DTH remote control emphasizes extreme energy efficiency, durability, and cost-effectiveness. Silicone rubber keypads are chosen because they provide tactile feedback to the user while offering a natural spring-back action that pushes the carbon pad away from the PCB the moment pressure is released, immediately reopening the circuit. The printed circuit board uses simple, single-sided or double-sided conductive tracks made of copper or conductive ink, making mass production affordable while maintaining robust reliability over years of repeated use. The microcontroller is optimized to remain in a deep sleep state for 99% of its life, waking up within milliseconds only when a button press closes a circuit, thereby allowing a standard pair of batteries to power the device for months or even years. In summary, the operation of a TV DTH remote control relies on a continuous chain reaction of mechanical, electrical, and optical processes. It transforms a physical touch on a silicone keypad into a localized electrical connection across a printed circuit board. This electrical event is interpreted by the microcontroller integrated circuit, which encodes the command into a structured digital signal. Finally, this digital signal drives an infrared LED to flash high-speed, invisible light beams across the room, allowing the user to control their television entertainment system effortlessly from a distance.